Today we are going to learn another one important part of the current electricity, that is electromagnetic induction. In the previous class we learned the electromagnetism, and also here we learn another one, electromagnetic induction. What is this electromagnetic induction? This is the coil. This is be a coil. This is be a strong bar magnet. When the bar magnet is at rest, the deflection of the galvanometer is not found. But when the bar magnet moves very fast, then what happens? Then we see that the galvanometer start to deflect. This is because of the electromagnetic induction. In a variable magnetic field, if the rate of change of magnetic flux occur associated with this coil, then there will be an EMF induced within the coil. As a result, the galvanometer deflects. That's why we see that the deflection of the galvanometer, needle of the galvanometer deflects in a particular direction. That means if the magnetic flux changes with respect to time, then an EMF will be induced within the coil. That is called the induced EMF, and the fact is called electromagnetic induction. There is an important question frequently asked after 2016 in board exam for alternate year. There are two laws related to electromagnetic induction. The first one is the Faraday's law. Faraday's law. Faraday's laws, there are two laws. The first law states that if there is a rate of change of magnetic flux associated with the coil, then an EMF will be induced within the coil. This is the first law. The second law states that how much amount of EMF will be induced, how they relate with each other. That is the second law. The rate of change of magnetic flux, if increases, the magnitude of the induced EMF also increases. That means the EMF induced within the coil is directly proportional with the rate of change of magnetic flux associated with it. If it is denoted by the induced EMF E, then E proportional the magnetic flux phi, E proportional d phi dt. D phi dt is the rate of change of magnetic flux. Very important question for board exam. Alternative year, you can see this in your question paper, 2 marks. Another one law is also here related to this, that is called the LENZ'S law. That is called LENZ'S law. LENZ'S law states that the EMF that is produced within the coil for which it is due, it opposes the every cause, and this is the LENZ'S law. Mathematically, here E proportional, a negative sign is introduced according to the LENZ'S law, and this negative sign indicates the cause for which the EMF is induced here in the coil opposes the every cause. That's why the negative sign indicates here E proportional minus d phi dt. Negative sign for the LENZ'S law. LENZ'S law obey another one MCQ question. Law of conservation of energy. LENZ'S law obeys law of conservation of energy. These are the frequently asked questions in your board exam for every year. Either Faraday's law of electromagnetic induction or LENZ'S law. Here the magnetic flux changes. That means the magnet moves very fast. The magnetic lines of force releases from the north pole enter into the south pole of it. When it moves, that means the amount of the number of the magnetic lines of force per unit area per second changes. That is the magnetic flux. That is why this is the electromagnetic induction, and these are the very important question. Faraday's law, LENZ'S law, and it obeys the law of conservation of energy. Law of conservation of energy. Law of conservation of energy. So this is very important for your board exam for 2 marks question and 1 marks MCQ. Okay. today up to this.